Alright, these are the notes on triangle congruence by angle, side angle, and angle, angle, coming from section 3.3 in the Math 2 book. We're going to start off with the postulate, which states if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. And if we look at the diagram here, we see that we have angle A congruent to angle D. We have the side length AC congruent to the side length DF, and angle C congruent to angle F. And it's got to be in that order. We're looking at an angle, well, two angles, and that side has to be connected to the two angles. And so if we read it in order, we say it's angle, side, angle. So the nice thing here is we can prove, if we can prove that we have this angle, side, angle congruence, then we can actually say that the triangles are congruent to each other. Normally, if you remember back to 3.1, to show that two triangles are congruent, we had to show 6 parts, corresponding parts congruent. Now we've reduced that to 3 parts here. And so angle, side angle is a nice way to show two triangles congruent. So looking at example 1, which two triangles are congruent using the angle, side, angle? So you're going to match two of these triangles, and one of them's not gonna be in the match. So pause this video, take a moment, and make a decision. When you have that, start back up. Okay, so here we have angle G and H are in between the side lengths. So GH is connecting the two angles we're interested in. So we definitely see angle, side, angle on this picture. In the second picture, we have two angles, but that side connecting the two angles, NI, we don't have that mark on it. Actually, the mark is at NF, and so if we were to read this, we would maybe say angle, angle, side. So the two angles are first, reading from right to left, and kind of going around that triangle clockwise, angle, angle, side. And then this third triangle, we have two angles that are marked here, and then the side between the angles, CA, is marked. And so we do have that angle, side, angle pattern. And so these two are using the angle, side, angle pattern, but are they congruent? Well, yes, because G is congruent to C. So angle G is congruent to angle C. We have angle H congruent to angle A. And lastly, we have side GH congruent to which side? Would I say AC or would I say CA? And you should say CA. And so which two triangles are congruent? Let's write our congruent statement. We say triangle GHO is congruent to triangle, okay, follow the order here, CAT. Example 2. We are here to write a proof now. We're given some information and asked to prove triangles congruent. So let's set up a two-way table proof where statements are on the left-hand side and the reasons on the right-hand side. And our first statement is always just to copy down the givens. So we got angle CAB congruent to angle DAE. We got side BA congruent to side EA. And angle B and E are right angles. So actually what I'm gonna put the same information but write it a little differently. I'm going to say the measure of angle B is equal to the measure of angle E, which is 90 degrees. That means they're both right angles. And the reason is this is all given to us. So we see all that marked in our diagram, and we need to come up with some kind of plan. We just talked about side angle side congruence, and we see that in the picture. We got these angles congruent here. We have these angles that we can state are congruent, and then the side in between them, between the two angles, are congruent. So we already have an angle and a side. Our second statement is going to say that angle B is congruent to angle E, which should be obvious. Our reason is going to be, well, we're using the fact that they're both equal to 90 degrees. And so because the measures are equal, the angles are congruent by the definition of congruent angles. And so now we have everything we need to prove the triangle's congruent. We have side angle side, and so we can end our proof stating triangle ABC is congruent to triangle AED, and our reason is side angle side congruence. And we have our proof. So the big thing here is to know, okay, I wanted to prove these triangles congruent by side angle side, and I need to make sure in my statements I have that. So I have here's side, here's another side, and an angle, and everything's there that I need. Let's look at another proof. So on this example, notice you have parallel segments. And whenever you have parallel segments, think alternate interior angles are congruent. Look for alternate interior angles. Almost always you'll find them. And in this case, I will put on the alternate interior angles. It'd be angle STQ and this angle here are QT. QT is in a sense our transversal, and the angle will always touch the parallel side. Okay, what you don't want to do here, you do not want to say these two angles are congruent. Okay, because those angles are not touching the parallel sides. So just be careful when you're picking your alternate interior angles. Those angles have to be created. One of those sides have to be parallel. And so in planning this out, we know that we can get these two angles congruent using parallel lines, alternate interior angles. We also have a shared side QT with itself using the reflexive property. And so now we have congruent triangles by side angle side. So let's write this up. We have our statement, reason. list possible givens, or list the givens, not possible givens. So we know that QR is congruent to TS. The line segments are congruent. And we also know that QR is parallel, that's the symbol for parallel, to TS. Okay, and those were given. Then there are a couple things we added to our list, and order does not matter, but let's say, okay, QT is congruent to itself. We need that. And the reason is the reflexive property. And then another thing we need is those two angles, the alternate interior angles. So angle, if you trace it, we say RQT is congruent to angle STQ. And the reason alternate interior angles are congruent. So we have everything needed now for side angle side, and so we can finish our proof here. So we were trying to prove that triangle QRT is congruent to triangle TSQ, and our reason that we're using, that's the, here's the statements we're going to be referring to. Side here, angle in between the side. So the angle between the two sides, so that's what we're saying, side angle side. And there we have it. Here's another theorem that we can use to prove that two triangles are congruent. This is the angle side theorem. And this theorem states that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So you can kind of see what's stated by looking at these pictures. So here we have two angles, but notice the side is not in between those angles. If the side were marked in between them, we'd have the angle side angle. But in this case, the side is not included in that process. So we're going to say angle side. Again, we got angle, well, angle E, angle D, and then the side DF. Okay. Before we go any further, I noticed I made a little error, and hopefully you noticed too. But if we go back to our proof in example 2, and I made the statement that the triangles were congruent by side angle side, that's actually not what we were doing, because we have two angles and a side in between. So this is, you should read angle side angle. So if you did not catch that, make that change right now. Sorry about that. So back here, we're adding to our list. So far there are 5 things we can do to prove triangles congruent. Okay, first thing we learned in our first lesson is using the definition of triangle congruence. And that's where you got to show 6 things are congruent to 6 things. You got 3 angles and 3 side lengths. A lot more work to do there. Then we started to introduce some shortcuts. In the second lesson we did together, we talked about the side congruence and the side angle side congruence. And now in this one we've introduced 2 more, angle side angle and angle. Now we're just talking about angle side. So as we approach triangles, as you're making proofs, even in the homework, keep this in mind. These are now we have 5 different approaches to prove 2 triangles are congruent. So here's the proof to Theorem 19, or at least an outline of the proof. So if we're given an angle side as drawn in here, note that if you know 2 angles, you automatically have that third angle. So we know that angle C and angle F are congruent by the third angle theorem. And then we have angle side angle. And so we can show that 2 triangles are congruent. So if you start with the condition angle side, we can use angle side angle to prove it's true. So here's what the proof would look like using their outline. So you have the statement, reason. Start with our givens. Angle A is congruent to angle D. Angle B is congruent to angle E. And AC is congruent to DF. Those are our givens. Because we have 2 angles congruent to 2 angles, we can use that. We get the third one for free using that third angle theorem. So that's what we're going to do. Angle C is congruent to angle F by the third angle theorem. And so when you're proving something new, so let's say we did not know Theorem 19, because we're proving Theorem 19, we have to rely on something that we've already known. So we can't just say, hey, they're congruent by angle side, because that hasn't, when you're proving that theorem, that has not been established yet. So we got to call on something that we know before that. So we're going to call on the angle side angle postulate. So that's what we have now. If you say angle A, side AC, and angle C, congruent to angle D, side DF, and angle F, which is angle side angle, and we get triangle ABC is congruent to triangle DEF. The reason is angle side angle congruence. So this is a proof that establishes the angle side. Because of this proof, we're now able to add that angle side to our list, and now we can use that as a reason when we're making proofs. Okay, example 4. We're making another proof here. A statement on the left side, reason on the right. State your givens. Angle S is congruent to angle Q, and RP bisects, which means cuts in half, angle SRQ. Those are our givens. So at this point, let's stop, look at our picture, see if we can figure out how to solve this. So based on the givens, they've drawn in that angle S is congruent to angle Q. But we have the second piece of information that RP bisects angle SRQ. So angle SRQ, if I trace that, start at S, SRQ, so that's that whole angle there. That's cut in half by RP. So now we can say that because it's cut in half, this angle here, SRP, is congruent to this angle here, QRP. And then lastly, notice we have a shared side. PR is congruent to PR. And so the pattern here is going to be angle, angle, side, which is the theorem we just proved. And we're going to use that now, angle, angle, side, to show that the triangles are congruent. So let's write that down. So we said that PR is congruent to itself. It's a shared side. And whenever you say something's congruent to itself, the reason we're using is the reflexive property. And then we also said that angle SRP is congruent to angle QRP. And the reason is in one of the givens. So RP bisects the angle SRQ. And so what does it mean to bisect an angle? It means to cut it in half. So we're relying on the definition of an angle bisector. So now we have in our statements, we have our two angles and our side in the order angle, angle, side. So we can finish our proof by saying that triangle SRP is congruent to triangle QRP, and the reason is angle, angle, side congruence. Example 5, we have another proof. So statement, reason. State the givens. So 1, PQ is perpendicular to QS, and RS is perpendicular to SQ, and T is the midpoint of PR. And those are given to us. So whenever things are perpendicular, we create right angles, and we see that in our picture. And since angle Q and angle S are both 90 degrees, we can easily get that they're congruent to each other. Also in our picture, notice that we have two segments crossing. Whenever that happens, you get vertical angles congruent to each other. And then lastly, T is the midpoint of PR. So that would make PT and RT the same length because T cut that in half. So now from our drawing we can get angle, angle, side congruence. So let's state that. Make sure all that is in our proof. So notice right now we haven't stated anything congruent to anything, and so we need at least 3 statements here. So Let's start with angle Q is congruent to angle S. The reason is we're using the idea of perpendicular. Perpendicular angles equal 90 degrees. They're both equal to 90 degrees. And so definitely relying on that definition of perpendicular. So from that definition, we get that the measure of angle Q is equal to 90 degrees, and also that the measure of angle S is 90 degrees. That's what it means to be perpendicular. Also, to add to our list of reasons, because the measure of the angles are equal to each other, we can say they're congruent because that's the definition of angle congruence. So we're also relying on the definition of angle congruence. So two reasons for part 2 here. We get a little more space. Okay, statement 3. So now we have one congruent statement. Let's also state that those vertical angles, we get angle PTQ is congruent to angle, let's see what letters up there, RTS. Because they're vertical angles, and vertical angles are congruent. And lastly, one more congruent statement before we can say the triangles are congruent, that PT is congruent to RT. That's because T is the midpoint, or the middle, of PR, and so we're using the definition of a midpoint. So we'll finish this proof off. Triangle PQT congruent to triangle RST. Why? Well, from the picture we see it's angle, angle, side congruence. And we've finished that proof. Example 6. Determine whether the triangles must be congruent. So in this picture, what do you think? You have MO congruent to MO, so you have a side between two angles, and so your answer would be yes, it's congruent by angle side angle congruence. Example 7. Again, look at this picture. Would you be able to write a proof based on this information? We're not going to write the proof, but would we be able to say that the triangles are congruent? Those arrows are indicating that we have parallel line segments. Look for alternate interior angles. Can you see where they would be? What do you think? Right here and here? Hopefully you're saying no, because those don't touch the parallel side. So you don't want to go with those two angles. Those are not the alternate interior angles that we're after. These are. Okay, again, I'll repeat, the alternate interior angles have to touch those parallel sides, the sides with the arrows on them. What else can we get? So we have, I should put 2 marks on these because it's already used up on 1 here. We have an angle congruent to an angle U congruent to angle R. That was given. And then we just found that angle UST is congruent to angle RTS by alternate interior angles are congruent. Okay. Can we get anything else? Can we say that US is congruent to TR? And hopefully you're saying no, because just because they're parallel does not mean they're the same length. But we do have this shared side. TS is congruent to TS. By the reflexive property. So we have enough information to say they're congruent. So we got congruent triangles. Why? Because of angle side congruence. So yes. Okay, so that looks like the end of our notes. You are on for homework. Work at those proofs.